Hello everyone, my name is Monomarine and I'm currently, as of spring 2020, a sophomore studying mechanical engineering at Johns Hopkins University. For my mechanics space design lab, I have decided as one of my final projects to dissect a DIY toy. As you can see here, I'm just showing you the different views of the toy. The DIY toy I've chosen to dissect is a critter wind-up designed by Chico Bacalo and manufactured by Kirkland Design Incorporated. The intended purpose of this toy is to wind it up and allow the critter to wander excitedly. From the company's YouTube video, I can estimate that the toy was manufactured around the early 2000s. But as an interesting fact, the first 100s were made from a surplus of vintage Japanese gearbox from the 1950s. The user interacts with the device by winding up the gears, and it seems to have a lever on the front which allows it to move up and down and wander across the surface. The store cost of this toy is $15.75. From observation, the toy works by using a gear train. It is initially winded up by hand, adding energy to a system that is stored in what it looks to be a torsional spring. This energy then moves a set of spur gears that is attached to the end of a small weight, which is one that causes the sporadic movement. The first component that removed was the key, which is winded up by the user to add energy to the system. I am now removing the nuts that are holding the legs of the critter. There are two pairs of legs that are each wrapped around the main screws that hold the body together, and the gearbox. Each leg was probably constructed from a longer rod that was cut and formed by rollers. At the end of each leg, as you can see here, has small plastic boots that are probably manufactured in mass using a casting method. And here you can see the top layer of the gearbox. Now I am slowly trying to remove the spring. Now, after I removed the spring, I was able to see clearly how the mechanism works. And from observation, it seems to be a simple gearbox. Now, looking closer at the gearbox, I can see the energy input, which is the longer rod, which then moves a series of gears, allowing the weight at the end to turn. I am also here showing how the string stored the energy. By spinning the internal tube, we were able to coil the spring together. In conclusion, this toy seems to be pretty sturdy. I feel like the designers had to maintain a high factor of safety due to the particular use of the toy. Since it's meant to bounce around and be pushed around, it also needs to maintain a certain strength, which probably the designers took into account. I am now just showing the different parts and how the cord wrapped around the main spring. These are just the different type of gears that we were using. It was all mashed together by using the same gear ratio, and which allowed, with a small energy input from the user, to increase the energy of the system, and thus making the weight at the end spin faster.